We're told the following graph shows y is equal to f of x, all right? And then the first question they say is, what appears to be the value of f inverse of 2? Pause the video and see if you can have a go at that. All right, now let's work through this together. So it's important to realize they're not asking us what f of 2 is. They're asking us f inverse of 2. F of 2, we would say, okay, when x is equal to 2, that's the input into our function. And then the graph tells us that f of 2, it looks like it might be a little bit more than 2.5. Maybe it's approximately 2.6. But that's not what they're asking us. They're asking us f inverse of 2. And just as a reminder of what an inverse function is, if we have some input x and we input into our function f, that is going to output f of x. Now, if we were to input f of x into the inverse function for f, then the output here, which is going to be f inverse of f of x, is going to get us back to this original x, is going to be equal to x. So we are really, in this scenario, dealing with this part of this chain of inputs and outputs. We're saying we want to figure out what f inverse of 2 is. So this part right over here is going to be equal to 2. So we're saying when f of x is equal to 2, what is the corresponding x? So when f of x is equal to 2, what is the corresponding x? We get 4. So let's write that down. F inverse of 2 is equal to 4. So when x is equal to 4, you input that. F of 4 is equal to 2, or f inverse of 2 is equal to 4. Now the next part, they say sketch the graph of y is equal to f inverse of x. So an important thing to realize is, if we're saying that b is equal to f of a, which implies that the point a comma b is on the graph of f, then we're dealing with f inverse. We would know that a would be equal to f inverse of b. You can think about swapping these two, the a and the b's here, which means that b comma a would be on f inverse. So any coordinate point that's on our original graph f, if you swap the x and the y, that's going to be on our f inverse. So let's just pick some points. And once again, they're just saying sketch, so it doesn't have to be perfect. So if we look at this point right over here, that looks like the point negative 10 comma maybe looks like 3.4. Well, then that means if we swap that x and y, it'll be on the graph of f inverse. So if we go to 3.4 and then negative 10, so it gets us right about there, that would be on the graph of f inverse. Now, if we went to, let's say this point right over here. This is the point negative 2 comma 3. So if negative 2 comma 3 is on the graph of f, then 3 comma negative 2 would be on the inverse. So 3 comma negative 2 would be on the inverse right over there. Let's pick a few more points. So we have this point right over here, 4 comma 2, which would be on the graph of f, which means that 2 comma 4 is on the inverse. So 2 comma 4, which would be right over there. And then if we look at this point over here, which looks like roughly 9, maybe let's just call it 9, negative 10. Maybe it's 9.1, negative 10. If that's on the graph of f, then if we swap that, negative 10, comma maybe 9.1 would be on the inverse. Negative 10, 9.1 right over there. And so then we could connect the dots to try to sketch out what the inverse function is going to look like, the graph of the inverse function. So it's going to look something like that. And you might notice it looks like it's a reflection about the line y equals x. It looks like it's a reflection about that line, which is exactly right.